So far we've looked at what cells are, how they were discovered, and then we looked at microscopes so you could actually see cells under the microscope. Now we're going to talk about why don't you see a giant cell walking down the street ever? Why can't cells be huge? The reason why is surface area to volume ratios. First we're going to go through the math of surface area to volume ratios, and then I'm going to give you some examples that will help it probably make more sense to you. So first, we have three different cells here. One is only 1 unit on each side big, one is 2 units on each side big, and here's 3 units on each side big. We're going to calculate the surface area, so how much area is covering the surface, the volume, how much space can be held inside, and then what the ratio looks like of the surface area to the volume. For surface area, so I'm going to come back to this example later. Think of a basketball for C and a ping pong ball for A. There's more surface area of the basketball because it's bigger, more of that leather on the outside, and it also has more volume. You could fit more into a basketball than you could a ping pong ball. And then we'll see what happens with this ratio. So first, figure A, how many total cubes do we have? There is only 1. The surface area, you're going to take length times width times 6 because there's 6 sides to a cube. In this case it says it's 1 unit or 1 centimeter on each side, so we're going to take 1 times 6. 1 times 1 gives us 1. 1 times 6 tells us the surface area is also 6. The volume is length times width times height. We have 1 by 1 by 1, which is still 1, multiplying. The surface area to volume ratio, now you're going to take the surface area divided by the volume, so 6 divided by 1 gives you 6. B, how many cubes are there? Well, we can see on the front 1 cube, 2, 3, 4, and then on the back side, here's 5, 6, 7, and then 1 in the back corner that we can't see because of this is a 3D image, but we know that there are 8 cubes. Surface area, well now we have 2 units big, and I just covered the 2. So for the surface area, you have to take length times width times 6. 2 times 2 times 6. 2 times 2 is 4. 4 times 6 gives us 24. The volume, how much space? Length times width times height. 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. The surface area to volume ratio, you're going to take 24 divided by 8 and reduce that fraction. If you reduce that, you get 3. If you're feeling comfortable with this, see if you can figure out C. So pause me, see if you can figure it out before I get to it. If you're confused, then stick with me. How many cubes are in C? Well, on the front I can see 1, 2, 3, 4, 5, 6, 7, 8, 9. And there are 3 total rows, so 9 times 3 is 27 cubes. The surface area, now we're up to 3 units on each side. 3 times 3 times 6. 3 times 3 is 9, 9 times 6 gives us 54. Volume, how much space is inside there? Length times width times height. 3 times 3 is 9, times 3 is 27. Ratio, 54 divided by 27, if you simplify that, we get 2. Let's analyze this. Look at the questions at the bottom. What happened to the surface area as the size increased? So as we got bigger, we went from A to B to C. What happens to the surface area, looking at this column as we go down the column? Well, surface area is getting bigger. We go from 6 to 24 to 54. That makes sense. Look at the pictures. A only has 1 unit on each side of surface area. B, we're getting bigger, so there's more surface area. C, even bigger, there's more of a surface, therefore there's more surface area. What happens to the volume? As we get bigger, we can hold more stuff. Volume is talking about how much stuff can be held. And if you look in here, the volume, as you see, as we go down, is also getting bigger. Lastly, we want to know what happens to the surface area to volume ratio. So if you look here, as our cubes get bigger, as our cells get bigger, from A to B to C, the ratio is going down. So why is this bad? Let me make it more relatable for you. and this is why surface area to volume ratios are important. Either listen to me reading this, or pause me, read it on your own, skip past, just go to the questions and the follow-up at the end. It's your choice. But if you want to stick with me, I'm going to read it right now. Yes, having a lot of surface touching the environment is good. More surface equals more places to get materials in and out. Yes, having a lot of volume is good because more space gives you more places to do stuff and store things. However, most cells are small because if they were to become huge, volume goes up, which is good. Surface area goes up, which is good, but the surface area to volume ratio goes down. This is bad. Here's why, using things more familiar to you. Imagine a ping pong ball and a basketball. Picture a dot smack dab in the center of each, floating in the open area of the ball. The outside of each ball represents its surface area. The amount of space inside each is the volume. Okay, now let's say you wanted to get some material to go through the wall of the ball and touch the dot in the center. It would be much easier to get to the center of the ping pong ball. It's smaller and you have less distance to travel. If you calculated it, the surface area to volume ratio is high, like it was for figure A in the table with the cubes. Go back and look at that table and see why. Now, you want to get something into the center of the basketball. There's more surface, good, and more volume, or more space inside, which is good, but it would be harder to reach the center because the center of the ball is farther from the surface. Sad. If you calculated it, you would see that the surface area to volume ratio is very small, like it is for cube C. Go back at the chart and look at that. This is why cells can't get big. When the surface area to volume ratio is small, that means the cell is big, it's too hard to get things in and out at a decent rate. If cells were huge, they would probably die before important things could get in and before wastes could get out. Let's analyze what we just read. If cells were big, their surface area to volume ratios would be small. The bigger the cell, the smaller the ratio. A small surface area to volume ratio makes it blank to get materials in and out. Well, if it's a big cell and that ratio is small, it means it's going to be a lot harder to get to the middle of that basketball. It's going to be easier to get to the middle of the ping pong ball because it's smaller and the center is closer. If it's harder to get things in and out of cells, cells are likely to die. If this confuses you, I have another video that I can show you that can help explain this in a different way. So if you are confused, see me before doing the Alice assignment, because otherwise you're not going to do well on that assignment. I'm sure that if you're confused, there are other people that are confused as well, so we could get a little group together and go through this in a different way. If it does make sense to you, then go to the crate, grab the Alice assignment, see your notes for what's coming up after that, and move on.